Welcome to this first lecture in chapter number 7 of this video lecture series with me, Joachim Stad from the University of Skövde, where we are discussing CCNA cybersecurity operations, or at least going through the materials of that course. Just as the previous chapters, this one will be separated into a number of different videos to make sure that I keep the videos rather short. And there are 3 parts to this video: network monitoring and tools, attacking the foundation, and attacking what we do. I want to tell you that I'm not really convinced that those titles actually say that much, and I want to point out that I'm not the one making the titles. We are going to start, of course, with part 1, network monitoring and tools, where we will basically discuss and present some different tools and approaches used for monitoring networks. And I want to begin with just introducing the defense in depth approach, which essentially is about combining different methods in order to get a thorough and good defense as far as network security go. You can also think about defense in depth as a method in where you implement security at different layers in your network. So for instance, you have some sort of edge security where you have security appliances for traffic that is entering and leaving your network. You will have monitors and security appliances within your network, and you will have endpoint security for your various hosts. And the 3 such techniques, if we want to group them rather largely, is first firewalls that we've discussed, intrusion detection and prevention systems, and of course different endpoint security techniques. So what I need you to know, or something that's important to know, is that a drawback of all those techniques is that they operate based on pre-configured rules, and they have a hard time detecting new threats. So whenever you want to implement firewalling, you will create rules saying that this traffic is allowed, this traffic is forbidden, and so on and so forth. When we have intrusion detection, we usually have signatures of harmful data that we want to block, and there are 2 things with this. Of course, new threats are hard to detect. We can do behavioristic stuff that we will talk about later, but anyhow, signatures will only catch what we have signatures for. There are also 2 other things, and those are false positives and false negatives. So no matter how good systems we build, they will never be entirely perfect. So we will either block stuff that we don't mean to block. This is false positives. A false positive is when an appliance raises an alarm, even if it shouldn't be an alarm. So whenever we detect OK traffic as harmful, that's a false positive, and we can possibly accept a certain amount of false positives, but this is going to have a direct impact on network performance, or at least how the network is perceived by the users. So for instance, if you have a user that wants to send an email and that email is blocked even though it's legitimate, that's a false positive, and the user is going to be mad. The other term, false negatives, that is when we accept, or when we do not raise an alarm for something where we should raise an alarm. And that's of course also very bad, because that allows us to that makes our appliances allow traffic that should not be allowed, and that may cause an incident or a big problem. So those 2 are usually are linked with one another. So the more as you decrease the number of false positives, you usually increase the number of false negatives, and the other way around. And this is because the way to get less false positives is to make the security policies more relaxed, and therefore we will have more false negatives. If we reduce the number of false negatives so we match everything that's harmful, well, then we need to have stricter rules, and then we will also have more false positives. And when it comes to security and the implementation of security, well, it comes down to what is the organizational needs, and how can we tweak our appliances so that we become as good as possible. Okay, that was a lot of talking for one slide. Let's go into monitoring methods. So something that's very important in security, at least if we want to be able to do some sort of behavioristic monitoring and threat detection, is that we have a good view of how our network normally behaves. And if we want to detect something hinky. That's basically the process of detecting whenever the network is not operating as it usually operates. Therefore, we need to have different tools in place that helps us monitor and establish like a baseline of what normal network usage and behavior is. For this, we can use a number of different tools like intrusion detection systems, NetFlow, SNMP, packet analyzers, and so on and so forth. And this, of course, then enables you to understand the normal traffic patterns, and that is a key part in detecting abnormalities. So, for instance, if you have a company in the US and you are usually only communicating within the US, then a large amount of data coming from Russia is something weird, and then an alarm should be raised. So if we talk a little bit about packet capturing methods, packet capturing is the process of collecting packages sent over the network for analysis. And you usually want to do this out of band, as with the discussion we had about intrusion detection systems. You put the packet analyzer or the analyzing software on the side, and then you need some way of copying network traffic from the network and out to the analysis device. And the material discusses two ways to do this, where the first one is using a network tap. And network taps are special built splitters that you insert into the network, and it will duplicate all traffic sent through it and send it on to a monitoring device. So this network tap is a piece of specialized hardware that you just put inline in your network. And the thing with those is that they are typically built so that they do not interrupt traffic if they should fail. So if the tap breaks down, the only thing that should happen is that the package capturing, of course, is not happening, but traffic should still be able to be sent as normal. The other method is port mirroring, and that is a method that can be implemented using SPAN, which you can read more about in the material. There are, of course, a long list of different tools you can use for monitoring, and I just want to mention some of them here, some that you will most likely work with within this course if you do the practicals. So one is of course protocol analyzers such as Wireshark, maybe also WinPCAP, and those or Wireshark is a tool which allows you to capture packages and then actually look at the data content of a package, so you can see the full protocol headers and the actual payload. Then we have NetFlow for monitoring flows. We have our CMs, we have SNMP, and of course other system logging tools or external logging tools. So let's formalize this term that we've used quite a bit throughout the course, which is the CMs, Security, Information, and Event Monitoring. So this is a technology used for real-time reporting and long-term analysis of security events, and a CM should include the following function. So first, it should enable forensic analysis, and in terms of a CM, we mean that this is the ability to provide a more complete information set that can be used for forensic analysis later on. So basically provide the information we need to have to say what is going on in our system. Then correlation, and correlation is a big thing with CMs, and correlation means the ability to correlate information from different sources, essentially taking and eating log files from different sources and present the log files that belong together to you. Aggregation, which is, for instance, to consolidate duplicate events. Reporting, which means that the CM should be able to report data in real time using some sort of fancy dashboard, and also give you long-time summaries of what is happening. And the thing with CMs is that in doing all of this, they are able to provide details on, for instance, the source of suspicious activity, so you actually know what IP address that is trying to do stuff to your network. So let me just mention two CM systems. A very popular CM that is proprietary is Splunk, and there is open source alternative called Elk that you can test in this course if you do the practicals, and it's basically made up from 3 different products that are created by the company Elastic. So the first one is Elasticsearch, which is a document-oriented search engine. So it's a very good search engine. If I'm not mistaken, it's actually used in some forensic appliances as well. I don't remember the names of them though. It also includes Logstash, which is a protocol system that, or processing system that allows you to connect inputs and outputs and apply filters in between. So the idea here is basically that you can take the input, apply some nice filters, and get the output you want. And finally, Kibana is also included in Elk, and Kibana is a web-based dashboard for Elasticsearch. So you can have a nice web-based dashboard when you to work with when you work. So, a rather short introduction to this chapter number 7. That was it. Feel free to leave questions in the comments field, and until next time.